Assalamualaikum and a very good day to you all. In this video, I'm going to talk about Castigliano theorem. Okay, Castigliano theorem is discussed in chapter 4.8 from the chapter 4 deflection and stiffness from strictly mechanical engineering design textbook. Okay, for engineering student, better you have the textbook with you so that you can refer. I hope this video will give some additional knowledge for what you have learned in your class. You can ask your respective professors for the knowledge lah. In this subtopic, there are calculations, there are examples given in the textbook. It's better you can review the textbook. You can get the textbook so that you can observe what I mean in the Castigliano theorem. Okay. So introduction to Castigliano theorem. Purpose of Castigliano theorem is facilitate deflection analysis in elastic system with small displacement, especially for indeterminate structures. Okay, small displacement. What does it mean by small displacement? Like my finger here, like your finger, like you put like this. Uh, this is small displacement, like this kind of displacement. Okay, meaning that naturally you cannot see with your eye, but theoretically it has displacement. Let's say you are jumping on the bridge. You are jumping on the bridge. You yourself are jumping in the large bridge. Nothing will happen in that bridge. Nothing will happen on that bridge. Okay, because you jump. Okay, you put the car, a lot of car on that bridge. Imagine in any bridges that a car come and to come, go forth and go back. Okay, nothing will happen in that bridge because the bridge can support tremendous load. Okay, but theoretically, mathematically, it has deflection, but that deflection you cannot see with your eye. Okay, this is called small displacement, deflection, and everything. Okay, the one that have deflection like this, like my finger go like this, deflection like this is using another theory like strain energy theory, deflection theory, integration theory, moment theory, and like that lah. Okay, what is discussed here in Castigliano is small deflection that you cannot see with your eye. Okay, but theoretically it has deflection. Okay, theorem states that displacement due to a force, that force direction is partial derivative of total strain energy with respect to the force. It is this subject, Castigliano, is also related to the strain energy, which is discussed in the previous video. Okay. Application useful in calculating both linear and angular displacement, making it versatile in practical engineering application. Okay. Mathematical representation of Castigliano theorem. There are mathematical representation. The equation is properly written in the textbook. You should refer to the textbook. Rotational displacement is also is properly written in the textbook. You should refer to the textbook. And application in analysis, it enables calculation of both axial and torsional deflection in various scenarios, enhancing precision in structural analysis. Okay. Procedure for using Castigliano theorem. First one is to define the strain energy. Uh, okay. And number two, differentiate for the displacement. And number three, to set up the strain, the Q as a zero lah. Okay. So practical, for example, for axial deflection expressed as this useful to precise calculation in axial loading case. Torsional deflection calculated in this equation to applicable in analyzing torsional deformation scenario, and efficiency in beam analysis. It excludes the transverse shear effects for beams with high length to height ratios, enhancing analysis for accuracy for long beams. Okay, so uh, that's all for the video right now lah. Okay. Again, the proper equation, the proper calculation is given in the textbook. Which is this is the textbook. You should get the textbook. And you read with you lah. I hope this video will somehow give extra knowledge for what you have learned in your class. Okay. Thank you very much. Okay. We meet again in the next video. Inshallah.